Okay, now I'm going to introduce you to the geometric mean. And so when we take a look at the sequence for -8, and then we have a missing number here, and then we have -32, we can kind of take a look here at the pattern, and we see, 4 times, oh, sorry, let me get my highlighter, 4 times -2 is -8, and we can kind of see this pattern where we're probably most likely going to have a common ratio of -2. And that's nice to see. We could plug in -2, multiply that through, and we would have our missing value of 16. Not all sequences and points of data are as easily solvable as our sequence that we have here, but I'll go ahead and show you the relationship between these values in a different way. Well, in a geometric sequence, the square of the middle term of any 3 consecutive terms is equal to the product of the other 2 terms. So if I were to find, if I wanted to find that value when I knew this information, I'd go ahead and I would take the square root of the product of -8 and -32, which is the square root of 256, which is equal to 16. So that is another quick way to solve, and we'll be going and solving an example in number 13 here shortly. But let's go ahead and get this definition going. The geometric mean of 2 positive numbers, x and y, is the square root of the product of those 2 values. Or we can go ahead and write this out as a sub n is equal to the square root of the product of the term below it and the term above it. So go ahead and write that in your notes and turn to page 4. So we all know who Wolverine is from the Marvel Comics, and there is a very dense, it's actually artificial, iron-based alloy that Marvel has come up with that is fused and bonded to Wolverine's skeletal and bone structure. So that is in Wolverine. It's called adamantium, and it's highly radioactive, and we have 2 points of data, 2 pieces of information that are given about the radioactivity. And so we would like to find the how many grams of this radioactive material is found in after 1 hour of the initial time, and also 3 and 4. And we can use the geometric mean to find these values. So let's go ahead and scroll down here. The first step that we are going to do is we are going to use the geometric mean to find the missing value at 1 hour. So to find a sub 1, we are going to take the product, the square root of the product of 1320 times 384, which is 711.955, which is approximately 712. So we're going to put in 712 at 1. We found the number of grams of adamantium left at 1 hour. Okay, so here is where we can use the definition of a geometric sequence, and we need to find the common ratio between each of these values. So if I take 712 and I divide it by 1,320, that is also the same ratio as 384 divided by 712, which is 0.539 repeating, and that becomes our R value. So we can go ahead and either use the explicit definition or a recursive definition to find hours number 3 and 4. And I choose the recursive just because we don't need to project any to any point in time beyond 4. So what I'm going to do is I'm going to build off of our last known value of 384 at 2 hours. So we're going to find the third term, a sub 3, by taking 384 and multiplying it by our common ratio of 0.539, which is equal to 208.72, or approximately 209 grams. Similarly, we can do the same thing with a sub 4. We are going to use our previous term, which was 209, and multiply it by our common ratio, and we end up with 113.6, or approximately 114 grams. And that concludes the geometric sequence videos.